Cool. So welcome, folks. How's everyone doing? How's life? Doing good. Perfect. Perfect. So real quick, I'm just gonna briefly start by introducing the course, and then today we're gonna jump into the first topic. So welcome everyone. Hopefully everyone found the right room. So my name is Niema Moshiri. I'll just kind of like basically every lecture, I'll start by outlining the goals of the lecture. I'm not teaching every single lecture. I actually have some cool guest lectures coming up that I'll highlight who may be giving some of the guest lectures. I'm still finalizing some of the details. But today I'm going to introduce myself, introduce the class. I'm going to give you an overview of what are the topics that we're going to be covering in the class. If you've already looked at Canvas, you've already gotten a sneak preview, but yeah, just kind of give you an overarching scope of what the class is going to go over. And then I'm going to end by talking about the very first topic of the course. So first, who am I? My name's Niema. You can either call me Niema, you can call me Professor Moshiri, whatever makes you feel comfortable. I'm fine with all those. My research area is in bioinformatics, so this is kind of the intersection of biology and computer science. So mainly, I personally work on developing computational methods and statistical models for viral epidemiology. So like studying the spread of HIV, studying the spread of COVID, any viruses that are of interest, that's kind of the space that I work in. In terms of teaching, I teach a lot of either intro CS courses, data structures courses, algorithms, bioinformatics courses. Here's a list of courses that I've been involved with teaching, but I usually teach CSE 100. So if we have any like CS majors, CE majors, math CS majors, there's a good chance you'll take CSE 100 with me at some point. I also do a lot of online course development. So I develop what are called massive adaptive interactive texts. These are kind of like online textbooks that you can engage with, do like problem solving and stuff. I also develop a lot of massive open online courses. So these are online courses that are massive and open for people to enroll. Welcome, come on in. In terms of hobbies, I'm a huge video game fan. That's kind of the point of this class. I also like watching movies, watching TV shows. I like audiobooks a lot. In terms of kind of subgenres of those that I like, in terms of video games, I usually like playing RPGs, especially Japanese RPGs. I like the Lord of the Rings franchise. I like reading or listening to memoirs. And I like learning about the history of technology, which is going to be the focus of this class. So in terms of the course structure, this is going to be an 8-week course, so emphasis on 8 weeks. So we're not going to have any class during weeks 9 or 10. So if you show up, I won't be here, but I guess you can hang out if you want. So each week we're going to be talking about a specific topic in video game history, and it's going to go roughly in chronological order. Some specific eras of gaming have a lot of different things that were kind of happening at the same time. So we might have a couple of weeks that are like in the same period, but on different focuses. But for the most part, as we go forward, it's going to be chronological. And what I'm really excited about is I'm going to try to have as many guest lectures from people actually in the gaming industry as possible. So yeah, hopefully it'll be a cool experience. This is my first time teaching this class. I'm kind of building the train tracks as we go, but I think it'll be a fun one. So after each lecture, so I don't take attendance or anything like that. After each lecture, you're going to submit a brief reflection, like 3 to 5 sentences, just talking about like what you learned in that given lecture. And that's going to be my proxy for attendance. So I do record these sessions on Zoom. I have to see for some of the future speakers if they'll allow me to, because there's like NDA issues. So I will typically be posting these on the internet, on Canvas afterwards. So if you can't make it for whatever reason, hopefully I should be able to have it there. If you can't make it and I'm not allowed to post the recording, you just click through the slides or just email me and I can send you some stuff to read. Where do you find that? Let me change tabs. So hopefully everyone has access to Canvas. So you're going to be submitting each of those reflections under that relevant week's reflection item. You can kind of keep track of which ones you've submitted by going to your grades section. So just kind of make sure that you submitted all of these. In terms of what else is on Canvas, so when I lecture, I'm going to be posting my slides. I don't know if all the different presenters are going to be using slides, but if they do, I'll also post their slides on there, and I'll post the recordings afterwards as well when I can. I also have a link to some learning materials. So these are just kind of materials that I personally thought were really interesting. Oh, this is kind of hard to read. These are materials that I personally thought were interesting for learning about different kind of pieces of video game history. I've left some stars next to the resources that I thought were like especially interesting. So I have like books, audiobooks, documentaries, YouTube channels, all that good stuff. You of course don't have to do any of this, but it's just there if you're curious. And then when I lecture, I'm also going to be highlighting which of those specific materials are relevant to that specific lecture. So if you want to like deep dive on a specific topic that you found was interesting, hopefully I'll have all the pointers that you need. Yeah, so no attendance tracking, just do all 8 of these reflections and you get an automatic pass, easy peasy. And yeah, everything related to this course is on Canvas. Hello, welcome, welcome. Come on in. Awesome. Okay, any questions about course logistics? Any concerns, comments? All good. So main thing is bookmark the Canvas page. Just make sure that you submit all those. If you forget any, I'll email you before the end of the quarter. So like there's no slipping through the cracks. But yeah, it should be a fun time. So overview of the course topics. So today we're going to just introduce the course, which we've already done. We're also going to talk about the very, very early origins of video games. Then second lecture, we're going to talk about how gaming looked like in the 70s. Then next lecture, how it looked like in the 80s. And then when we get to the 90s, this is where it kind of fractures into a bunch of different topics that each kind of deserve their own lecture. So in the early 90s, we're going to talk about the console war. So this was kind of between Nintendo and Sega, which Sega doesn't make consoles, but you might have played some of their games nowadays. But they used to make consoles. We're also going to talk about how console gaming looked like in the late 90s. So like the PlayStation coming out, Nintendo 64, kind of those OG. I think probably what some of you folks are like familiar with is like the earlier retro consoles that you might have actually played. And we're also going to separately talk about PC gaming. So PC gaming like really had a big boom in the late 90s. Also in the late 90s, I guess this is kind of an extension of PC gaming, but a little bit separate, was the rise of MMORPG. So nowadays, every game that you play has some like massively online aspect to it. Back in the late 90s, when we were on dial-up, that wasn't super easy. So this was like really the early days of how do we even create online games that can have a bunch of players that are interacting with each other. And then the very last lecture, because I had to kind of squeeze a bunch of stuff, it's going to be like 2000s onward, which is unfortunate because there's a lot of like distinct things within that period. But for the most part, I think starting in the mid 2000s, gaming has kind of become somewhat standardized. So I think it'll be okay. Welcome, welcome, come on in. So just as a sneak preview, I still have to confirm with them just to make sure, but I have some guest speakers coming from Blizzard Entertainment. So I don't know if folks are familiar with like Diablo franchise, Warcraft, World of Warcraft, Hearthstone. Oh, perfect. Exactly. So I have someone from Blizzard who I'm trying to get for one of the lectures. Someone from PlayStation I'm trying to get for the last lecture. They're gonna, I'm assuming, probably talk a lot about their cloud gaming, but I'm hoping all the gaming from like the PS3 onward. I have some cool authors that wrote some of the books that I'm linking to. Some YouTubers that you might be familiar with. So I don't want to like name names yet just before they confirm, but it seems like it's going to be likely. So it'll be a cool time. Any questions about this overview? Any concerns, comments? All good? Okay, so let's jump into the first topic. So today we're going to talk about the super, super, super early on days of video games. So recommended reading for this section, I think this book is my favorite on this topic. It's called Replay. And what's interesting about it is he actually doesn't go into necessarily like the most popular games. He goes into what were the most like historically important games. So like the first of its kind in a given genre or in a given kind of historical setting. So really cool book. Highly recommend. There's an audiobook. Actually, all the books that I list, I believe all of them have audiobooks that are for free on Libby. So if you don't have a San Diego library card yet, you should definitely get one. Great resource. Also relevant, but not quite as relevant, but kind of comes up at the end of this lecture. There's this book, Hackers by Stephen Levy, that talks about like computer hacking and like kind of the early days of computers writing efficient programs and like kind of hacker ethos of that day. So yeah. I'll kind of start with a discussion question. So what is a video game? And maybe like take a second to think, maybe even feel free to like chat with your neighbor. What is a video game? If you had to like define it to someone, feel free to like mingle, or if anyone wants to like venture a guess, we could just have a discussion as a whole group. Any thoughts from anyone? Yeah, go for it.
Yeah.
Okay, so you're saying, okay, so you're saying from the name, there's kind of the video aspect, and then there's the game aspect. So video, you're saying there needs to be some kind of a screen, and then the game aspect, you're saying, well, what's a game actually? Entertainment, so some type of entertainment. So it was like watching a movie on my phone, a video game. It's got a screen, it's entertaining.
Like a simulation.
A simulation, okay. Interactive, okay, I like that. And then was that what? Interactive, absolutely. So interactivity seems to generally be one of the main things that video game tends to encompass. We had mention of like video of a screen of some sort. Any other thoughts, or are folks kind of content with that? So some type of like video display entertainment that is interactive in some way. Make sense? Okay. And it makes sense because PlayStation as a company, it's like a subsidiary of Sony, but they've like rebranded as Sony Interactive Entertainment. So that kind of encompasses pieces of it, what everyone has mentioned. Okay, so we have an idea of what a video game is. What does it look like? Like if you had to like describe what a video game looks like, either how to play with it, how to like what the video feed is, what does it look like in general? Any thoughts?
Depends on what type of video game you're playing.
Depends on what type of video game you're playing. So what's like some examples?
Like good one is Minecraft.
Minecraft, okay.
Usually sort of cubic, bright colors. It's meant to be sort of engaging
Okay.
towards the viewer.
So bright colors, some video feed. How do I play it? Like what do I interact? Because everyone mentioned interactivity. So how do I interact with this colorful cubic screen?
You need like a controller or keyboard, mouse, or any sort of device that allows you to give inputs into the video game.
Awesome. I like that. So you mentioned inputs. So there needs to be some type of like input interaction mechanism, that there's some peripheral of some sort. That you mentioned a controller. So we have like modern controllers that have been fairly standardized nowadays. When we talk about early consoles, there's going to be some really weird looking controllers before they had kind of some of those standard details figured out. You also mentioned mouse and keyboard. So a keyboard that I use for productivity, I could use to enter commands or controls into a game. Any other types of interaction that folks are familiar with? Yeah, go for it.
The example Minecraft, I think this would be like big out while taking it, or like the other games where you're not, I guess, first person perspective would be just like interact with objects, kind of complete whatever goal that they set out to do.
Okay, so some type of like goal, some type of like progress-based gameplay. So there's some type of like progression through the game in a sense. Okay, I like that. Yeah, go for it. Joystick. So joystick is another one. So I don't know if folks have played games in arcade, but like especially the like helicopter games or like the airplane shooters. Usually you have like a stick that you're kind of controlling, and there's a button on top. Did you have an idea as well?
Yeah, physical movement, like there's a camera sensor or something.
So that's a great one. Yeah. So a camera where we're not actually touching anything, but I remember I grew up with, so when I was in high school, the Nintendo Wii had come out, and that was like one of the first consoles that you had like motion controls. That was pretty wild. The Xbox 360 had the Kinect, where it was like a physical camera that you like interact with. Even before that, the PS2 had, I think, I forgot what it was called. But they also had like a little camera peripheral of some sort that does visual. Okay. Any other interactions? Have people played like shooting games in an arcade of some sort? Like House of the Dead or Time Crisis, or are those too old?
Virtual reality controllers also count.
Virtual reality, absolutely. Yeah. So you have some handheld controller that you're moving. Absolutely. There might be motion control, there might be button presses. Yeah.
On like the light blasters for the games like the rail shooters, like House of the Dead and stuff.
Exactly. So there's like light gun peripheral. So it's effectively a controller, but you might be shooting it at a screen that has some sensor of some sort. When I grew up, DDR was a big thing. I don't know if DDR is still a popular game, but Dance Dance Revolution. So you have like a mat that you step on the buttons associated with. So still effectively a controller, but just different interesting shapes and sizes. And then I guess the last one I'll mention is I remember when I was a kid, the GameCube had this like Donkey Kong Jungle Beat game that there was like a drum that you hit, like a pair of congas. So all sorts of wacky ways. Okay, so hopefully it's become clear that all of you had very different images of like what a video game could be. So it's a really big umbrella term. So I want to walk you through what were like the first video games. And to do that, I want to give you a couple different definitions of video games. So there's an early kind of technical definition of a video game that this is one of the first definitions. It's not as widely agreed upon anymore, but the very early definitions, well, first of all, clearly for something to be a video game, it has to be a game. So there's this game component of it that's important. That's actually not a very obvious definition. So, this holds for all definitions of video games because the term game is in all of them. But like, what is a game is actually a very long discussion that like would probably require its own course. So we're going to table that discussion for now. Let's assume that we've agreed upon this is a game. What about the video part? So the very early technical definitions really focused on the video part of video game. And the early definitions required you to have some video signal that you're transmitting to some display. Welcome, come on in. That display could be a CRT, it could be an oscilloscope, etc. So for folks that might not have seen CRTs, I grew up, we had a CRT in our house. We didn't have this type, I'm not that old. But, you know, there was like the old cathode ray tubes where there's like a little tube at the back that's like shooting light signals onto the screen and kind of painting the screen in lines. In the early days, there was also oscilloscopes that they had games that could like be played on these weird little squiggly line drawing things. So early definitions, you had to have some hardware that was sending some video signal to some display of some sort. However, this excludes text-based games. So there was very early text-based games that like they output the results to some teletype, or actually some of them would print out physical paper print of the game playing. So this is an early image of output from the Oregon Trail. I don't know if folks have played that before. It's like a very old game where somehow you like are trying to go west and then your whole family dies of dysentery or something like that. That's kind of the overarching summary. But like this game actually would print out what's going on, and like you would type in your commands and then they would show up in the text on a physical printer. So this would not technically count as a video game under the strict definition. It also excludes games that use some static LCD graphics. So when I was a kid, LED and like dynamic LCD technology wasn't very advanced, but they did have technology that you could actually have like fixed, kind of like I don't know if folks have seen like alarm clocks that have like the fixed kind of light bulb things that like some of them turn on or off. The technology behind these old video games, you actually had like kind of clock-like technology where each of those individual kind of display pieces are their own bulb, and you're just kind of dynamically turning them off or on. There's no video signal being transmitted. So this definition would also exclude video games like this. So yeah, so under this definition, these kind of counter examples that I listed, you'd probably call them electronic games or computer games. More recently, there's been kind of a broadening in the definition of a video game. So today, usually it's not as hardware dependent. In general, the modern definition kind of necessitates that the game has to be played on some type of hardware that has electronic logic circuits. So you actually have to have effectively a computer that's processing some gameplay logic on some electronic circuit. The game also has to have some element of interactivity. So if you don't do anything to interact with it, it doesn't fall under the definition of video game in the modern definition. And the hardware has to output the results of a player's action to some display. It's not requiring you to send a video signal, but there does need to be some type of display of some sort that's showing the user what's going on in the game. It could be a screen, it could be text printed onto paper. As long as there's some type of dynamic graphics that are like changing as a result of the user's interaction, any such display is okay. Even this definition might be a little bit strict, and we're actually going to explore some of the early video games that actually don't technically count as the first video game under this definition. Okay, so any questions so far? Folks with me? Awesome. Okay, so another discussion question. So when was the first video game invented? Don't look it up, but just out of curiosity. So today is 2025. When do you think the first video game was made? Any guesses? Yeah, go for it.
Maybe during like
Early 80s? Okay. When the first computer was in it? When was that? ENIAC? Okay, so we're actually going to talk about the ENIAC. So hold on to that thought, but okay, so some other old computer that may or may not have been invented in the 80s or maybe earlier, depending on our recollection. Any other thoughts? Yeah, go for it. 1960s, okay. So we got 60s, 80s, and whenever the ENIAC was invented, which we'll talk about in a second. Okay, so let's jump in. So first, we have to talk about the world's first programmable computers. And we're actually going to go all the way back to the end of World War II in 1945. So August 14th, 1945, Imperial Japan surrendered in World War II. And very shortly after that, the first programmable computer was operational in February 14th, 1946. And actually, World War II was very significant for the development of computing. I'm going to talk about it in a little bit. but the first completely programmable computer was actually invented in 1946. It was called the ENIAC. It was at UPenn. And here's a picture of what that first programmable computer looked like. So now your phone is like orders of magnitude stronger than this behemoth, but here's a photo of two individuals actually configuring like the logic of this programmable computer. You have to like plug and move these plug boards on this like room-sized device. So it cost $500,000, which in hindsight, I should have probably translated that to what that equates to in modern dollars, but like much more than 500 grand in modern dollars. And it took 3 years to build. So in 1947, Alan Turing, who's like commonly known as the father of computer science, he wrote the first chess program in 1947. So here's a photo of Alan Turing. He was actually like super important to the war effort in World War II. He did a lot of work cracking the Enigma code. There's a movie about him that I highly recommend. I'm blanking on the name of it. I think The Imitation Game,
Yeah.
if I remember. Yeah. So that's a good movie if you're interested. So is it 1947? Alan Turing wrote the first chess program. Do we have our first video game? Call it a day? Fortunately, no. So the program that he wrote was so complex that none of the computers that existed at the time could even run it. So technically, he wrote the first chess program, but it's not really a video game if you can't play it. Okay. So moving a little bit forward in time, Thomas T. Goldsmith and S.L. Ray Mann built an electronic game in 1947. So real quick, I'm going to show you. This is Thomas T. Goldsmith. And it was called the cathode ray tube amusement device. So CRT, those types of like boxy displays, that's called the CRT, cathode ray tube. This was an amusement device that they, I think they patented, they had prototyped and like kind of designed. And it was basically a game type thing that was simulating an artillery shell that was like arcing over the cathode ray tube towards some target. So you're kind of like trying to shoot some targets with some artillery shell. The targets, they weren't actually images rendered on the screen. You would paste like a plastic overlay on top of your screen, and then the game just knows that your screen should have these plastic overlays. So it was trying to like shoot these things that are just kind of like fake plastic on top. So very, very, very primitive. And then what you would do is you would actually like adjust a knob on the device to adjust the trajectory of the beam to try to hit those targets. But unfortunately, and this is why this one reason why it doesn't count is that it was never actually manufactured or marketed to the public. It was all just kind of theoretical. They patented it, but then nothing ever happened. Another reason why we don't consider it the first video game is that there was no computing device. It was just a solid circuit that like the user just turns a knob to hit stuff, but like there was no computing device that was doing any type of logic. It was purely just trajectories on an oscilloscope or on a CRT, I guess, but yeah. Okay. So we're getting a little bit closer. We're getting some interactivity. We're able to theoretically play it, but this one was never actually created and no computing device. So a little bit further, this is kind of one of the common contenders for the first video game. There was a game named Birdie the Brain that was invented. It was built for the 1950 Canadian National Exhibition, and it was built by Joseph Cates. You can see over here. So this was this 13-foot tall tic-tac-toe video game that was built using a special electronic tube called the Adatron tube. And I think the Adatron tube, Joseph Cates had actually invented. And this was a game that was meant to just prototype that technology that he mentioned. In a lot of those early games, the games weren't the point. There was some other technology that the games were just trying to like demo, hey, look at how cool this technology is. But regardless, tic-tac-toe game using this special device. And basically your gamepad, you had a 3x3 keypad, and you would basically click on where you wanted to play. And it looked like this. So over here, you have this big grid of just a tic-tac-toe board with X's and O's. And there's a little control pad over here that you click on what you want to play, and then it displays here, and then it can tell you if you won or lost. Okay. So yeah, so under some definitions of video game, some people consider this to be the first video game ever made. It was the first interactive game running on a computing device. However, according to the more modern definition of video game, there was no moving graphics. You just had fixed light bulbs that might turn on, but it wasn't like kind of changing as you're playing the game in any interesting way. Okay, so I'm going to pause here. Any questions? Good. Okay. So we're going to go a little bit further into the future. There was a game built called Nimrod, and it was built for this thing called the Festival of Britain. So after World War II, for very understandable reasons, the whole world was a little bit sad. So to try to bring some like excitement and joy to the UK, the Festival of Britain was first launched in 1951. I think Winston Churchill was the one that like instigated that it would happen. So it was this big festival that was in the UK, and a lot of it was to try to highlight like science and technology that was being built, but just generally have like a fun fair for people to play around with. So as part of this, there was a computer company called Franti that promised the government that it would create some type of a display or some type of an exhibit for this festival. So one of the employees at Franti, John Bennett, created the company's festival exhibit. So here's John Bennett, and he invented, basically he wanted to create a computer that could play a parlor game called Nim. So I've actually never heard of this game called Nim, but basically you place a bunch of matches in a bunch of piles, and then players take turns drawing at least one match, and whoever draws the very last match wins. So you could draw one match, you could draw two matches, you could draw three matches, but basically you take turns going around the players, drawing some number of matches of at least one, and whoever can draw the last one wins the game. And I think there must be an upper limit, because I imagine you can't take all but one of them, or all but, I don't know. So I'm not too sure about the details, but some type of a game of like pulling matches. So he built this machine called the Nimrod. So it was 12 feet wide, 5 feet tall, and then 9 feet deep. So again, really, 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 really big, that you could play this game using matching light. So somehow these colors, I think, correspond to the matches that you could take. And then you interact with it using, I think, this switchboard thingy over here. And then you can kind of play this game of Nim on this machine. Okay. So some people argue this was the first video game, but the people that say it's not say, well, there was no moving graphics. Again, just like with Birdie the Brain, you have a bunch of light bulbs that just turn on or off, but they're not actually like changing during the gameplay. It's just kind of like it turns on and then it stays on or it stays off. It's not like dynamic. Okay. Everyone with me? Awesome. Cool. Okay. So we're getting a little bit further into the future. So in, I think, British English, they call the game of tic-tac-toe Noughts and Crosses, but there was a Noughts and Crosses game that was created for the EDSAC. So Maurice Wilkes, he was like a famous computer scientist back in the day. He built the first computer that had random access memory in 1949. So on your computers, you might be thinking like, oh, I have like 8 gigs of RAM or 16 gigs of RAM. So RAM didn't exist in the old computers. You turn them off and then like nothing persists. And when you turn them on, like nothing persists in memory like longer than the immediate execution. So having memory that you could like store variables and then access those variables just didn't exist until 1949. Here's a photo of Maurice Wilkes. And that computer that he built was the electronic delay storage automatic calculator, EDSAC. So early computers computing, it was really meant to be like a big automated calculator. So yeah, he built this big machine. Here's a photo of the machine. Again, we have like these super huge machines. I guess this is a photo from 1948, so it wasn't done yet, but kind of in the process of being built. So Sandy Douglas, one of Maurice Wilkes' PhD students, wrote his thesis in 1952. Here's a picture of him a little bit more recently than 1940s. So he wrote OXO, which was an implementation of tic-tac-toe on this machine. And some argue that this was also the first video game ever made, but again, it had no moving graphics, just things would light up, just like with the Bernie the Brain. So again, doesn't quite fit the definitions, but one of those contenders. It also wasn't accessible to the general public. So a lot of those other machines that I told you about, there was like some exhibit or some fair that random people in the community could play this game. This one was purely stuck in the academic setting. No one could actually play it outside of academics. Okay. Any questions so far? Yeah, go for it.
So, games are two-player or
Good question. Are they 2-player or are you playing the computer? So I believe for all of these, the intention was for you to play against the computer. I think some of them had a way for you to play against another human. But the kind of interesting thing was, can we build a computer that can play these games with us? Yeah, great question. Awesome. Any other questions? Okay, so a little bit more into the future. And I think this first lecture, it's going to be a little bit drier because these are really old and really primitive computers. But once we get a little bit further into the future, it'll be a little bit more exciting. But so Art Samuel, he wrote the first ever checkers program for the IBM 701 in 1952. IBM is a company that you might all recognize. International Business Machines, it still exists. They're still making computers. So here's a picture of him demonstrating his checkers program back in 1956. So he actually has a checkers board in front of him, and then he like translates his move into some type of like non-intuitive control for the computer to be able to interpret. The computer then, I think, changes lights or somehow changes some other type of primitive display, and then he translates that into some type of gameplay on his physical checkers board. So again, some people argue this is the first video game. It's actually playing checkers. If you translate what your moves mean into the computer's logic, it can actually play back to you, and then you can translate its moves back into actual checkers board moves. But again, a lot of people with the more modern definition say, nuh-uh, there was no moving graphics here. You have to actually move the pieces yourself, so this doesn't count either. Also, just like with the previous one, this is not accessible to the general public. This was like a very kind of like high-level prototype that was just meant to show how advanced can this machine compute. Okay, it was like a very academic tool. So fun fact about this program, though, again, I mentioned in the early days of computing and even somewhat in modern days, games were largely used as a prototype to try to learn something about computer science or about engineering. So the reason why Art Samuel created this checkers program was because he wanted to create a program that could self-learn checkers strategy. So this was actually one of like the pioneering developments of the entire field of artificial intelligence, where he thought if we can teach a computer how to play this real human game, that might help us solve other real world problems that we want to solve. A game is nice because it's well defined, there's a clear objective, there's a clear winning strategy, or maybe not even always a winning strategy, but at least a clear way of defining who has won the game. So yeah, he thought teaching computers to play games would help us with any general tasks that we might want to solve as well. So the program used what's called a search tree of board positions that are reachable from the current game state. So we actually, in the program's logic, encoded from a blank grid, what are some of the gameplays that this is actually like, this is for tic-tac-toe, just to keep it simple, but like imagine that, but for a game of checkers. So at any given kind of checkers board state, what are all the different moves that the current player can play? So he encoded that in what's called a search tree that kind of shows level by level, this is the initial state of the board. This is all the possible first moves stemming from that one. This is all the possible second moves, with these ones stemming from here, this one stemming from here, this one stemming from here. You'll notice that it's not actually showing every possible position. So here there's in the center, there's in the top middle, there's in the diagonal. All the other positions that you could play are just different rotations of this. So that's usually one of the early techniques of like condensing this super big tree into a smaller space where you kind of map equivalent moves onto the same state. But imagine this, but for a game of checkers. So this program could actually learn from its mistakes using a technique called rote learning. So this is one of like the early artificial intelligence algorithms where basically, I guess I don't describe it there. So basically what it would do is it had some objective function that knew when it wins, what is its like score that it's encoded as like a winning score. And anytime it would do poorly based on that score that it's trying to optimize, it would remember what moves led to that point, and then it would downweight those decisions compared to other decisions, and it would upweight decisions that seemed to be successful down the line. So this is like one of the very early days of like artificial intelligence and like learning automatically while it's playing a game. And actually, it was so good that in 1961, so like less than a decade after he first wrote it, it was able to actually beat US checkers champions. And this was like a big deal because up to this point, computers and computer programs are so primitive that like an actual expert could wipe the floor with any computer program that someone could make. So now we're actually showing, hey, computers can do really crazy stuff. Okay. Folks with me still? Any questions? Okay. So the next one is what is agreed upon under the modern consensus as what is the true first video game. This was a game called Tennis for Two. So William Higginbottom, I don't know if anyone watched the movie, shoot, what's the Yeah, Oppenheimer. Sorry. Yeah, I was like, what is the movie that just came out? Yeah, so I'm assuming people watched Oppenheimer. If you didn't, it's a great movie, very long. So the Manhattan Project was the US's kind of development of the atomic bomb. Uh, and here is William Higginbottom. So William Higginbottom, I guess, do I not have details about what he did? So his job in the Manhattan Project was he was building the timers that timed when the bomb would go off to make sure that it goes off at the right time. So I think in the movie, he was the one that was portrayed by, I think, Josh Peck, who was in that movie for some reason, like the Drake and Josh guy. So he's the one that like handles the timers to make sure like it doesn't prematurely explode or it doesn't not explode. So a lot of scientists that worked on the Manhattan Project were very kind of troubled by what they had created. So actually, a lot of them, including William Higginbottom, after the war campaigned against nuclear proliferation. There was like this big post-war, let's destroy our nuclear arms. Let's like deproliferate in the post-war world. So as part of his post-war efforts, he then also became the head of the Brookhaven National Lab. So the US has a few different federal national labs that kind of do very private, very advanced research. And Brookhaven would hold annual events where people from the general public could come and see like what are some of the technology things that people are working on in this national lab. Your taxpayer dollars are going to it, so we should show you, hey, it's actually worth it. So Higginbottom, he wanted to create a fun exhibit for people to be able to play with, which was called Tennis for Two. And then here's a picture of what the setup for Tennis for Two looked like. Here is the little screen that the game was actually playing on, and you would control it using these little knobs that I guess people have probably played Pong in this class, maybe. Yeah, it's very old, but you might have played it where like you have the two bars on the side where you got a ball that's like moving and then you just kind of move it up and down to hit. So it was a very primitive version of that, where two people can control little knobs to control their respective bars, and then there was like a physics-based trajectory of a ball that would like bounce between them. And this was a huge hit. People really loved this, and it like blew people's minds. It's like, whoa, I can actually play a game with this computer. So back to your question, this one was two people playing with each other. This one wasn't the computer playing against you. So yeah, it was a tennis game built with transistor circuitry, and it played on an oscilloscope screen. And then under all these definitions, this is typically considered to be the true first video game ever made. So it had a computing device and it had moving graphics. Okay. Folks with me still? Questions, concerns? So now, as of 1958, we've built the first computer. So a bit older than the 80s, actually later than the ENIAC. So good guess on that one. But yeah, this is like the first true video game. So I'm going to build up in this lecture from here. Now we have the first one. I'm going to also go up until the beginning of like kind of commercialized public-facing video games. So before I can introduce where video games went next, I have to teach you about MIT's Tech Model Railroad Club. And you might be wondering like, wait, what? Model railroads? How do we get here from computers? It's very weird, and I don't know why this is the case. I didn't go to MIT, but apparently MIT has a Tech Model Railroad Club that was formed in 1946, where, as the name implies, they liked building really, really elaborate model railroads that used different relays and switches and like different circuitry to do really crazy stuff. So I couldn't find any old photos from like the 1940s or 50s, but here's a photo of one such railroad that they built in 1996. So the members of the Tech Model Railroad Club, they were also super passionate about computing, and they were super passionate about sci-fi. So through that, so they were like just generally very passionate about technology. And unlike a lot of professors or computer scientists at the university at the time, they were mainly focused on like building for the sake of fun rather than building for the sake of like research progress and technical stuff. So they were very focused on fun rather than practical value. So in 1961, there's a company called the Digital Equipment Corporation, DEC, which gave MIT a PDP-1 computer. So the PDP-1 was like one of the first mainframe computers that was like purchasable by individual institutions, not like the National Lab has a single machine, but this is actually something that individual institutions could reasonably purchase, or in this case, it was given to them, but like not quite consumer grade, but not quite only a handful of people in the entire world have one. So it was expensive. It cost $120,000, which is like $1.3 million in 2024 dollars, but still big research grants could theoretically pay for something like this. And it was really big. That's going to be the general consensus of all the computers that we're seeing. So here is a display of the PDP-1 computer. This is actually at the Computer History Museum in Mountain View, California. I don't know if folks have ever been. I heard a couple Bay Area people. You should definitely check it out. It's super cool. I felt really bad when like stuff from my childhood was on the Computer History Museum because I'm like, I don't think I'm that old yet, but it's okay. You all will experience that one day when they have like Minecraft as this is what the kids played back in the early 2000s. So this over here is the PDP computer itself, the PDP-1. And then the PDP-1, this machinery is just doing the number crunching itself. So how do you actually interact with it? You have a console typewriter that you can like type programs into. And how do you then see what it's doing? It could either print stuff back at you, or there was this CRT display that could render really, really, really primitive graphics. So it's still dynamic rendered graphics that it could send. So one of the members of the Tech Model Railroad Club named Steve Russell wrote Space War in 1962, and this was one of the first video games that actually got played at multiple institutions. So here's a picture of Steve Russell. So back in those early days, people that had these PDP-1 computers, which again, not your average person, but like maybe a school or a university or like a department would have one, and you can actually communicate with them across what at the time I think was called the ARPANET, kind of the predecessor to the internet. You can actually like connect to other computers in this academic framework and access the game. So this guy, he wrote this game called Space War, where basically you have two spaceships that are trying to shoot each other while they're maneuvering in the gravity well of a star. So stars have a lot of density, they have a lot of mass, so therefore a lot of gravitational pull. So when you're near a star, you get kind of like sucked into it. So it's this game where like your spaceships are kind of like constantly getting sucked into the star, but also like trying to move around and like shoot each other. So it looks something like this. And also this display is at the Computer History Museum as well. So highly recommend checking it out. Bless you. Yeah, bless you. So this is one of the first early games that actually got distributed broadly. Again, it was still within the academic community, but then you'd be able to have like undergrads at other institutions be able to like access the computer lab and then play around with it if they could get access to a PDP-1, which depending on who your advisor was, you might be able to. Okay, so I want to kind of pause here and highlight, we started with like very early military related stuff. We transitioned to, okay, now we're prototyping some technology, but still only a handful of people have access to it. Now we're getting a little bit more generalizable, where it's a machine that multiple departments or institutions can theoretically purchase. And this game can now travel a little bit. It's still within higher education, but like you all are undergrads at a university, so you would theoretically be in the pool of people that might be able to access it. So now we're getting more and more consumer facing. So one of the last topics that I'm going to talk about today is called the brown box. So there's this guy, Ralph Henry Bayer. He was born in Germany in 1922 as Rudolf Heinrich Bayer. And here's a photo of him that was taken in 1977. He was a big pioneer of like video games. So Bayer's family, who were Jewish, as you might guess, they fled to the US right before World War II. And he survived, so he served in the American War effort. And through the American War effort, he actually got a lot of interest in technology right after. So after World War II, he went and worked as an engineer at this company called Loral Electronics back in 1951. So Loral Electronics, it was, I believe, do I have mentioned? Nope, I don't mention there. So I believe it was a defense contracting company. So again, in the early like 1950s and like that time period, all of computing was like really focused on defense type stuff. So it was a defense contractor. But when he joined, he got the idea of, imagine you could play a game on a TV. And at this time, commercial TVs were available. So I showed you that picture of that CRT TV. You could actually, if you were a relatively wealthy family, purchase a consumer grade CRT for your home. So the ability to play a game on this TV, it's not out of the realm of possibility. It's theoretically feasible, but a defense contracting company, for kind of obvious reasons, wasn't super interested in it. So later on, oh, actually, whoops, maybe I mixed them up. I guess Loral Electronics was not the military contractor. Sorry. Later, he went to Sanders Associates. That one was the military contractor. And in 1966, that's when he revisited the idea. I think he was pretty high up in this company, so he was able to pitch it and actually get a little bit of resources to work on this. And he created a device that he originally called the Channel LP, where LP stood for Let's Play. It was kind of, actually, he didn't get approval, never mind. He did it in secret with Bill Harrison and Bill Rush. So I guess kind of on their side, they were building this device called the Channel LP that was meant to be some type of like game playing TV system. And then later on, they renamed it to the Brown Box, and they almost finished it in 1967. But when they then showed it to their higher ups at this military contractor, those military contractors were not interested in this video game device. And here's a photo of what the Brown Box looked like. So it was actually multiple different games, and it's kind of hard to see in this picture. If you look at the slides later, you can see it a little bit better. You could pick what game you wanted to play by adjusting those knobs. And those early computers, a lot of it was flip knobs to put it in whatever mode that you want it to be in. So here, this is a target shooting video game, and it actually had like this gun-looking peripheral that you could then like shoot the gun at the TV display, and it'll interact in a similar way as like, I don't know if folks have seen Duck Hunt from like the early Nintendo games. It's like birds are flying and then you shoot it. Same type of idea. But there was a lot of different games that you could play on this thing. So I'm gonna pause. Does this look familiar to anyone? There's actually another thing that we're going to talk about in a future week that, yeah, go for it. So it looks like Duck Hunt, absolutely, but the console itself. So like, ignore the gun. The gun I just included because it shows that you had cool peripherals, not just little knobs. But the Brown Box itself, like this stuff, does this look familiar to anyone? Any thoughts? You don't know what? Kind of hitting those core memories a little bit. Okay, so we're going to talk about some computers in the 70s that keep this box in mind. It's going to be a sneak preview for what you're going to see soon. Okay, so we have 2 minutes left. What comes next? So this is kind of the natural ending point of this, where what have we talked about? Well, we talked about a lot of early attempts to create video games. And I want to emphasize a lot of these were highly restricted. And that's why most of you have probably not heard of any of them, or maybe you've heard of like 1 or 2 of these. Some of these were purely academic projects that you just couldn't access it if you were in the general public. Even if you could access it in the general public, it was usually through special exhibitions. You couldn't just go buy one and play it at home. So it wasn't really for regular consumer usage. And then some of them were meant to be sold to the general public, but none of these actually succeeded in their commercialization. So everything kind of failed before you could take it to the consumer market. So these early attempts, they largely failed because the cost of computers was way too expensive. So putting a computer that's small enough and cheap enough for an average person to be able to buy for their home just didn't quite exist yet. But computers were getting really cheap, really fast. And by the early 1970s, computers would finally become cheap enough to commercialize. So this is going to be kind of the ending point of this lecture. And next time we'll talk about those early computers and therefore the early video games of the 1970s. So let's go ahead and end it there. Actually, we're right at 50 after. Nice. Any questions or anything before we head out? This is really old video games, but the later ones are going to be maybe a little bit more recognizable to you all. Cool. Okay. So thanks so much for coming, folks. Thanks for listening to me ramble out really old video games. Again, I have some resources that I pulled from for this lecture if you want to read any further on any of these. Most of this lecture was from this book over here. The MIT Railroad stuff was from this book. And yeah, don't forget to do your reflection, and I will see you all next week. Awesome. Thanks, folks.